Hi there, in this video I'll be using the PhET simulation circuit construction kit DC Virtual Lab in order to look at the current in a series and a parallel circuit. So I have a series circuit up at the top and almost a complete parallel circuit down at the bottom. The reason why it's not complete is I've found after using this app for quite a long time that there's actually a limit on the number of wires you can place. Now that's 25, so what I'll need to do actually, I need 4 wires for the parallel circuit. So I'll show you the series circuit to start with, delete 4 wires and then use them to complete that parallel circuit. Now, looking at the series circuit at the top, I've got a battery here, I have a switch, 2 lamps, and at 3 different positions within that circuit I've placed ammeters in order to measure the current in amps. So when I close that switch, first of all, obviously if you look at the ammeters you can see the current is the same at all points, and that's very important. Now, the second thing I can see is I can see that the electrons are moving round this circuit anti-clockwise. Now, in Scotland, we talk about electron current. So the direction of current, I would say, is anti-clockwise in this circuit. But some people in other countries and using other systems would actually talk about the current being clockwise. And that's because in some countries, if I click here, they use conventional current. Conventional current is the flow of imaginary positive charges, and that would be from the positive terminal, which is on the right hand side of the battery, clockwise round to the negative terminal. So this is conventional current, but what we use, or at least what I use in Scotland, is known as electron current, and that's actually anti-clockwise in the circuit. Now I don't know if you noticed, but it doesn't matter which system you're using, electron current or conventional current, the current at all points is the same. And in this circuit is 0.45 amps. Now what I'm going to do just before I show you the parallel circuit is I'm going to change the resistance of this lamp on the right, and I'm going to make that higher, which means that the resistance of the whole circuit is larger, and that actually affects the current in the circuit. It actually decreases the current, and now the current at all 3 ammeters is 0.3 amps. Now, for certain reasons that I'll not go into in this video, this lamp on the right hand side is brighter. That's more related to the voltage across it, in fact, not the current, because the current in both of these lamps is exactly the same at 0.3 amps. Now we've reached a point where I'm going to open that switch. I'm going to delete 4 of these wires, 1, 2, 3, 4, and that means I can then complete this parallel circuit like so. 1, 2, 3, and another one makes 4. So there's my parallel circuit, much the same, except of course these 2 lamps are in parallel. This ammeter is obviously in series with the top lamp, and this ammeter's in series with the bottom lamp. Close the switch, and what do I see? Well, I see that the current in the main part of the circuit is 1.8 amps, but once we get down to this position here, in fact, I can see that some electrons are going up and some are going down. So some are going through this lamp at the top, some are going down and then through this lamp at the bottom, and then of course at this point they both join up and back to the positive terminal of the battery. And if you look at the values in the ammeters, I can see that that 1.8 amps is splitting, so that we have 0.9 in the top branch and 0.9 in the bottom branch. So at least in this circuit the current's splitting evenly. So current in a parallel circuit splits. Now, why it's splitting evenly is because the resistance of that top lamp is 10 ohms, the resistance of the bottom lamp is 10 ohms. What I'm going to do now, in fact, is I'm going to increase the resistance of the bottom lamp to 20 ohms, like so. So now the resistance of the bottom branch is twice the resistance of the top branch. Now, overall, in fact, the resistance of the whole circuit's actually increased, and that's meant that this current in this part of the circuit is actually decreased to 1.35 amps, but it's no longer splitting evenly. What's happening now is that the top branch has a current of 0.9 and the bottom branch now has a current of 0.45. Now note, of course, at all times these 2 currents, 0.9 plus 0.45, will add up to the current at this point. But it's not splitting evenly because the lamp at the bottom has twice the resistance. So because this branch has twice the resistance of the top branch, it ends up with half the current. Now, why don't you actually try this simulation yourself? Build series circuits, parallel circuits. See if, like me, you can build a circuit which is large enough that you can use all 25 connections you're allowed to use. But that's an awful lot of fun using this. For now though, that's us. We'll see you in the next one.